Hi everyone, welcome back to my YouTube channel SK Tech. In today's video, we are going to discuss runtime polymorphism. So in our previous video, we have already seen there are two types of polymorphism available in Java. First is like compile time polymorphism and second is like runtime polymorphism. So in today's video, we are going to discuss runtime polymorphism, and we have already discussed compile time polymorphism, which I am going to share the video link in this description section. So do check out. So what is runtime polymorphism? So similar to the compile time polymorphism, runtime polymorphism is also called dynamic method dispatch. So instead of resolving the overridden method at compile time, it is going to resolve at a runtime. So basically, what are the method that is going to be called, that is going to be decided or going to be resolved by the compiler at runtime. That's why we call this as a runtime polymorphism. And runtime polymorphism can be achieved by using the method overridden, right? So what is method overriding? So when there are a same method present in both superclass, that is nothing but the parent class, and subclass, that is nothing but the child class, with exactly same signature. So same signature in the sense, in compile time we have seen that can be different in terms of the number of the argument, type of the argument, or order of the argument. But in case of method overriding, it can be same in both the parent class and in the child class. So let's see what are the rules for overriding the method in Java. So first rule is like there must be inheritance between classes, because it is going to be parent-child relationship or superclass subclass relationship, and that can be achieved using the inheritance. So the first rule to be defining the method overriding in Java is there must be inheritance between classes. And second rule is like method between these classes must be same. So what are the method available in superclass? The exact same method should be available inside the subclass. Definition can be anything, but the signature wise it should be exactly same. So name of the class, number, and type of the argument must be same in case of method overriding. So let's see some of the example and we'll understand in more. So first example that we are going to discuss about like animal class. So let's say we have an animal class that is behaving like a parent class in this case, and let's say we have one method called place. So if you can see, place method signature is like void place, and then inside that it is having some definition. So definition can be anything. For example, we have written like animal lives on earth, right? Now let's say we have another class, dog class, that is behaving like a subclass because it is extending the animal class, and here also it is having same method like void place and some definitions. So if you can see, superclass and subclass is having same method, it means that this method can be called as overriding the place method from the superclass to subclass. So this is nothing but called as a overriding. And another, let's say another class is also having horse class, again the same extending the animal class. So this horse class also will become like a subclass only. And here also if you see, this horse class also overriding the same place method only from the similar to the superclass and having some different implementation. And even if you can say, if you have another method, let's say rabbit, and if it is extending the same animal class, so this class also become like a subclass only of the animal. And since it is overriding the same method, void place and some definitions, so this method is also here is like behave like a overriding the method from the subclass to superclass. So this is how method overridden is defined. When the same method is available in both parent class and subclass with the same signature, implementation can be different, is called method overriding, and this is also used to achieve the runtime polymorphism. So let's see how it can be achieved. So let's say we have a created animal class object A equal to new animal class. So here A is behaving like a parent class because animal A is having the animal types of object only. So that's why it is behaving like a parent class, and using this object, if we call the place method, it is going to print the implementation of the parent class, something like animal lives on earth. But same thing, let's say if the same object creating and defining the different object like subclass object, in this case let's say dog, and then we are calling it the a dot place method, same method only, then it is going to behave like a child class. Okay, and since it is behaving like a child class of the dog class, in this case it is going to call the dog class implementation, like dog lives in kennel. And similar to that, again in the same object, if we are providing the horse type object and calling the place method, this object is going to behave like a child class of the horse and it is going to call the horse place method. And similar goes to the rabbit. So if we run this program, you will see here animal class object first time is calling the place method. It is going to behave like a parent class because this A is nothing but the same object of the animal. But in this case, it is going to behave like a dog class. In this case, it is going to behave like a horse class. And in this case, it is going to behave like a rabbit class. So same method we are calling. So for the end user, this definition or this resolution will be done at runtime. So that's why this is called as a runtime polymorphism. So if you run this program, you will see the output something like this. For first place method, it is printed like animal live on earth. Second, it is printing like dog live in kennel. Third is printing like horse live in stable. And fourth, it is printing like rabbit lives in burrow. So if you can see here, we are not changing the object variable, right? Object variable of the animal class, same variable is used, but the assignment is different. So this is something like it will decide at the runtime. Let's say we have some couple, everything should be handled at the web page side, right? So let's say if someone is going to page on the animal class, when he hit that, then it will come to the backend side and will create the object. So if the implementation is something like this, animal A equal to, in case of dog, it will create like something new dog. In case of horse, it will create like new horse. So something like that. So that definition, it will be decided at the runtime. What are the consumer is expecting or entering the page detail or going to the page detail, those kinds of object will be created and those kinds of functionality will be invoked. So that's why this is decided at the runtime. So that's why it is called as a runtime polymorphism. So this is the one of the example. Let's see some another example similar to the animal. Let's say we have a shape class, something like this. So let's say we have a shape class. So this class will behave like a parent class because this is not extending anything. And let's say it is having one area method, void area and some implementation. Let's say we have another class square method and it is extending the shape class. So means this shape, this square method is going to behave like a child class. And since it is overriding in the sense, and since it is implementing the same method similar to the parent class method, so this method will become like a overriding the method, and implementation can be anything specific to, let's say, the square. Similar goes to the rectangle. It is again behave like a child class because it is extending the shape class only, and it is having the override method of the area from the super class, and it is having your own implementation. So implementation can be anything, but if the signature of this method is same to the parent class, so this will become like a overriding method and this class will become like a child class. Similar to that, it can be have a circle. Again it is extending the shape class, so this circle class will become like a child class and shape is nothing but the parent class. And again it is implementing the area method only with some definition according to the circle, and then this method will become like a overriding method. So similar to the animal class, again we can create the shape class object, and using the shape class object, if we are calling area method, then it is going to print the area method functionality of the shape class. Why? Because we are assigning the shape class object. But in the same object, if we are assigning the square class object, then it is going to behave like a square class, and when we are using the same variable calling the area method, it is going to call the functionality of the square. Similar goes to rectangle and circle. So if you run this program, you will see the output something like this. So since in the main class what we are printing, formula for areas, and here area of square, area of rectangle, and then area of circle. So similar to that, it is printing like formula of areas, area of square with this, and with this it is printing like area of rectangle, and with this it is printing like area of circle. So this is the another example of the runtime polymorphism, because this definition or this resolution is decided at the runtime, which class object we are assigning to the shape class while creating the object. Based on that, it is going to call the functionality. We have seen animal class or example, we have seen shape class example. Let's say how it is behave like a real time scenario like banking domain. So similar to the other two example, there can be a, let's say we have a bank. Let's say we have one method called rate of interest calculation, and by default it is not returning anything, let's say. And let's say we have a ICICI bank who is extending the bank class. So it means that this class method will be automatically available here, and if ICICI also implementing the same method with the same signature, so this will become like a overriding the rate of interest method from the parent class. So here ICICI bank can implement their own rate of interest similar to the ICICI. If again some other bank is there, let's say SBI, and extending the bank class, so this SBI will behave like a child class, and he can also override the same method which is available in the parent class and define their own implementers like another different rate of interest. Similar to that, it can have another method also. Let's say for example HDFC again is extending the bank class only, again it is implementing the rate of interest same method which is available in the bank class. So this class is nothing but the child class behave, and this is like overriding the rate of interest method. And here according to the HDFC, he can implement like their own rate of interest, let's say 9.4%. Similar to that, another bank can come, Canara Bank, other bank, Axis Bank, and so many banks that come, and they can extend and they can behave like a child class, they can override the method. So at the runtime, if user so let's say we have an implementation like this. We have created the bank class object, and first time inside the bank class object, let's say we have assigning the ICICI, and we have write some logic in the UI side. Let's say someone log in into the ICICI bank, and if they want to calculate or they want to use the rate of interest functionality, they'll click on the rate of the interest. So internally it is going to assign the same ICICI object inside the bank. Then this bank will behave like a ICICI, and it will return the output like rate of interest of ICICI something, whatever the ICICI have decided. Similar to that, if someone is going to log into the SBI, same, it is going to use the same variable, it is going to call the same rate of interest method, but this time it is going to behave like a SBI. Similar goes to the HDFC also. See, so this decision basically made at the runtime. So wherever user is going, he is going to log in, it is going to calculate the rate of interest. It does not matter where it come from, but in the backend side, it is like it is going to use the same instance variable with the different types of the object, and based on that it is going to decide what are the rate of interest it should return. So if you run this program, it is going to print something like this: rate of interest of ICI something, what are the definition it has been implemented, and then for in case of SBI, in case of HDFC, something like this. So this is the another example of the runtime polymorphism, where the call of the method or call of the functionality of the class is decided at the runtime. That's why this is called as runtime polymorphism. So if you see here or in all the example we have seen, this same variable is behaving differently based on the different types of the assignment. That this same variable behaving like a ICICI, this B variable again behaving like a SBI in this case, here in this case it is behaving like a HDFC. So same variable is behaving differently in case of this situation, means as per this situation. So this is called polymorphism, and since this is decision is making going to be at runtime, so that's why it is called runtime polymorphism. So here we have seen runtime polymorphism is this we are achieving for the method type, right? So let's say if we have a variable type, so that variable also is going to be overridden or not in the child class, and is going to be achieved using the polymorphism or not. So let's say using the data member, if we implement the same logic, is it going to work or not in Java? So if you see, let's say we have a parent class and we have a data member, let's say int value equal to 50, and let's say we have a child class who is extending the parent class. So it means that this variable will be automatically available inside the child class. But if child is also defining same variable, it means that as per the overridden concept, this will be this will be overridden, this variable will be overridden, and now value is 100. Now let's say if we create the parent class object and assign the child class objects, and using this object, if we call this variable value, what it is going to print? So as per the method overridden concept, in case of the method, it was calling the child class methods, right, in this scenario. But in case of variable, let's say what it is going to print. So if you run this program, you will see something different. Yeah, so if you see here, what it is printing, child value is 50, even though inside the child we have overridden this variable, right, but still it is printing 50. That is because Java does not support basically data member to be overridden. So basically data member cannot be achieved polymorphism. That is the important point that you have to remember. Polymorphism can be achieved using the method overloading, not the data member overloading. Okay, so that's all for today's video. In next upcoming video, we are going to discuss some characteristic of the polymorphism, advantage, disadvantage, and some important interview question also about the polymorphism. So stay tuned. We'll meet you soon. Thank you.